Okay, so hello and welcome back. So the next thing that we have here is exercise 10.1, I suppose, in which you want to find negative 4, 5. So the points are negative 4, 5, 0, 7. 0, 7 is over here, 5, negative 5 is over here, and negative 4, negative 2 is over here. So you would get this quadrilateral. Now you want to find the area of this quadrilateral, and in order to find the area of this quadrilateral, this is the formula for finding the area of a triangle once the vertices are known. For example, the area of this triangle over here, PQS, for example, area of triangle PQS is equal to, basically, you can use this formula and you can use these points, for example, negative 4, negative 2, and then you can use negative 4, 5, negative 4, 5, and then the other point, for example, 5, negative 5. So that would be, for example, 1/2 times the absolute value of x1. You can take this as x1, y1, x2, y2, x3, y3, the next point. Now x1 is negative 4 times y2 minus y3. And you need to check this formula. Negative y2 minus y3, y3 minus y1, and y1 minus y2, which is correct. So y2 minus y3 would be 5 plus 5. So 5 plus 5. And then x2 is negative 4 times y3 minus y1. So that's negative 5 plus 2. Negative 5 plus 2. And x3 is equal to 5 times y1 minus y2. So negative 2 minus 2. Negative 2 minus 5, I'm sorry. Negative 2 minus 5. And then you can write this as 1/2 times, basically negative 4 times 10, negative 4 times negative 3, and negative 5 plus 2 is equal to negative 3, and plus 5 times negative 7, and that's equal to 1/2 times negative 40, negative 12, negative 35. Now you have negative 40, negative 12, negative 35, which is equal to 40, 12, and 35 is equal to 7 and 87. So that's 87 halves. 87 halves. So this is equal to 1/2 times 1/2 times basically 87, 1/2 times 87, which is equal to 87 halves. 87 halves. Now the area of the other triangle the area of the other triangle, let's say the area of triangle QRS, So you can take the points as negative 4, 5, 0, 7, 0, 7, and 5, negative 5. So that's equal to 1/2 times the absolute value of x1, which is negative 4, times y2 minus y3. 7 plus 5. 7 plus 5 plus x2. x2 is basically 0, so I don't have to write it, and x3 is equal to 5 times y1 minus y2. y1 minus y2 is equal to 5 minus 7. y1 minus y2 is equal to basically 5 minus 7. So this is equal to 1/2 times negative 4 times 12 plus 5 times negative 2, and that is equal to 1/2 times negative 48, negative 10, and that's 1/2 times the absolute value of negative 58. That's equal to 1/2 times 58, which is equal to 20, which is equal to 29, or let's just simply write it as 58 halves. Now the total area of this is going to be the area of quadrilateral is equal to 87 halves plus 58 halves, and these are all in square units, and this is also in square units. So 87 plus 58 is equal to 8 plus 7 is equal to 15, 1, and 145, that's 145 halves square units. Now I don't understand why I'm making a mistake here. Now let's go see what the solution looks like. So to find the area, so triangle ABC, triangle ACD, okay, so now let's do it based on the solution that they have. Therefore the triangle ABC is equal to 29 units. PQS and 63 There is something that I'm doing wrong and I don't really know what that is. That's the problem. So I'm just going to change these over here to A, B, C, and D. And then the area of triangle ABC area of triangle ABC ABC, so I write this as basically what they have done is -4, 0, and 5. -4, 0, and 5. So I write it as -4, 5, 0, 0, 7, and 5, -5. And then over here I can write this as 1/2 times the absolute value of x1, which is -4, times y2 minus y3. So 7 plus 5 is equal to 12. Plus x2, which is equal to 0, plus x3, which is equal to 5 times y1 minus y2. So 5 minus 7. 5 minus 7. 5 minus 7, which is equal to 1/2 times the absolute value of -4, times 12 plus 5 times -2. Which is equal to 1/2 times -48 minus 10, which is equal to 1/2 times basically the absolute value of -58, which is equal to 1/2 times 58, and that's 29. 29 square units. Now the next thing that we have is the area of the other triangle. The next thing is the area of triangle basically ACD, and I'm going to take it in the exact same order that they have taken it, ACD. So -4, 5, and -4. -4, 5, and -4. Okay, so triangle ACD, I can write them in this order, meaning that I can write it as -4, for example, -4, 5, and then 5, -5, and then -4, -2. So then this I can write as 1/2 times the absolute value of, for example, -4 times y2 minus y3. So that's -5 minus y3, so that becomes +2. And x2 is 5 over here, times y3 minus y1. So that's -2 times, I'm sorry, -2 minus y1. So -5 plus x3, which is equal to -4 times y1 minus y2. So 5 plus 5. So 5 plus 5. So then you have 1/2 times basically -4 times -3 plus 5 times -7 minus 4 times 10, which is equal to 1/2 times +12, -35, -40, and that is equal to 1/2 times the absolute value of, so you have 75 plus 12, so 75 minus 12. 75 minus 12 is equal to 63, so that's negative 63. That was the mistake that I was making. I was calculating this wrong, and I did that many times, 3 times I suppose. Okay, so that's 63 halves square units. So now the area of quadrilateral, the area of the quadrilateral ABCD is equal to basically 29 plus 63 halves square units, which is equal to basically 2 times 29 is equal to 29 times 2 is equal to 18. 1, 58. 58 plus 63. 11, 1. That's 121. 121 half square units. So that was the first example here. So now the second example or exercise is the base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at the origin. Find vertices of the triangle. Okay. Okay, so the next question is the base of an equilateral triangle. So you have an equilateral triangle. You have an equilateral triangle, and the base of this triangle with side 2A lies along the y-axis. So of course you know that when you have an equilateral triangle, all the sides are of the same length. That means that the sides are of, basically you can say, of side length 2A along the y-axis such that the midpoint of the base is at the origin. The midpoint of the base is at the origin. Now you can imagine that, for example, let's say that this is 2 units and this is 2 units, and so if the midpoint is over here, the triangle is either probably, I don't know, is either this way or the other way around. In any case, this length over here is basically, you can say that this length is 2A, and this length over here, is A, because this point is the midpoint of this side. And this is the y-axis and this is the x-axis. Now this triangle, of course, could be the other way around, meaning that this vertex could be over here. Along the y-axis such that the midpoint of the base is at the origin. Find vertices of the triangle. Okay, so So if the length of this side is 2a, if the length of this side is 2a, you can say that this distance is a. So if this distance is a, you can say that the coordinates of this point is 0, a, and then the distance of the coordinates of this point would be 0, negative a. And then the third point, and then of course you know that the coordinates of this point would be 0, 0. And of course you know that this side is 2a as well, meaning that this distance over here is 2a as well. So I can I can calculate this length over here, meaning that I can write 2a whole squared is equal to basically a squared plus, for example, if I take this length, if I take it as, let's say that I take this length over here, let's say that I take it as h, I take this as h, for example. If that's the case, that's equal to h squared. So then that means that 4a squared is equal to a squared plus h squared. So basically 4a squared minus a squared is equal to h squared, and 3a squared is equal to h squared. So h is going to be equal to the square root of 3 times a. So h over here is square root of 3 times a. Square root of 3 times a. Now, so basically the coordinates of this point becomes square root of 3a, 0. Square root of 3 times, 0. Let's see what the answer actually is. So then the vertices would be 0, a, 0, negative a, and square root of 3a, 0, or basically you can say 0, a, 0, negative a, or square root of 3a, 0. Meaning that if the triangle, if this vertex is over here, then of course this coordinate becomes negative square root of 3, a. But otherwise this is right, and the other case would also be right. Anyway, that was basically the answer here. Question number 3 is find the distance between find the distance between P, x1, y1, Q, x2, y2, and when PQ is parallel to the y-axis, when PQ is parallel to the y-axis, and number two, when PQ is parallel to the x-axis. When PQ is parallel to to the x-axis. Okay, so here we have basically two formulas that we need to derive from the formula, the distance formula that we had. So we said that if you have 2 points P and Q, meaning that if P is equal to x1, y1 and Q is equal to x1, x2, y2, then the distance PQ generally is equal to the square root of the square root of x2 minus x1 whole squared, x2 minus x1 whole squared, plus y2 minus y1 whole squared, and that's called x2 minus x1 whole squared plus y2 minus y1 whole squared, and that's called the distance formula. The distance formula. Now if you have any 2 points if you have any 2 points, for example P and Q, you can take this point as, for example, x1 y1, and take this as x2 y2, or you can take this point as x2 y2, and you can take this point as x1 y1, and then substitute these values in the formula, and then get the distance between the 2 points. Now in case basically there are these two special cases. Of course there could be many other special cases to this formula, and this is the general form of, you could say, the general form of this formula. You see over here, if you have any point, if you have any line which is parallel to the y-axis, for example, let's say that you have this, you have these, you have, for example, let's say that this is P and this is Q, and this is the x-axis and this is the y-axis. So then PQ, the line segment, is parallel to the y-axis. Now when that's the case, of course you see that there is no difference between your x's, meaning that x1 is equal to x2. In this case x1 is equal to x2, and since x1 is equal to x2, of course their difference is going to be 0, and 0 squared is going to be 0. So you can write this as PQ is equal to the square root of y2 minus y1 whole squared, which can be written as y2 minus y1, because you're using the square root function as a, basically this is definitely a positive value. Since it's a positive value, then of course you can write it as y2 minus y1, and so PQ is equal to y2 minus y1 when PQ is parallel to the y-axis, or you can say when PQ is a vertical line segment. when PQ is a vertical line segment. Now, when PQ is a vertical line segment. Now, and that makes sense because, well, of course, the difference of your x's is 0, so there is only, suppose that you have these two basically points at the same x. If you have these two points at the same x's, of course, the difference between two points is, or the distance between these 2 points is going to be x2 minus x1. And that, there you might have a problem as well, meaning that suppose that you have these 2 points over here. Suppose that you have this point P over here, for example, 3, comma, for example, 5, and you have this point over here, for example, 3, comma, negative 3. So the distance between these 2 points is actually 8 units. The distance is actually 8 units. Because you have 5 units over here and you have 3 units over here, so the distance is 5 units. Now let's use the formula that we found over here. PQ is going to be equal to, for example, let's take this number as y2, and let's take this number as y1. In that case, basically y2 is going to be equal to 5 minus y1. 5 minus y1, 5y1 is going to be equal to negative 3, and that gives you 5 plus 3, which is equal to 8. Alternatively, you can take this as y1 and you can take this as y2, and then PQ would be equal to still y2 minus y1. So you have negative 3 minus 5, which is equal to negative 8. But the distance cannot be a negative value, so I think then you should just simply write it as the absolute value of y2 minus y1, and it's going to work for you. Now there can be another case when PQ is parallel to the x-axis, somewhere up here or somewhere down here, and let's say that this is now, for example, your PQ over here, and in that case, of course, you know that your y is not changing, so this part becomes 0. So then PQ becomes the square root of x2 minus x1 whole squared, and that is equal to basically x2 minus x1. And again, here you could have the same problem, meaning that for example, let's say that you have these 2 points over here, for example, let's say that this is 2, comma, for example, 3, and over here they have negative 3, comma, 3, and the distance between, let's call this P and let's call this Q. The distance between P and Q is going to be equal to, of course, your x is negative 3 here, your x is 2 here, so the distance is 5 units. Is 5 units. Now, based on the formula, if I take this as, for example, x1, if I take this as x2, then x2 minus x1 is going to be equal to 2 minus negative 3, which is equal to 2 plus 3, which is equal to 5. There you have no problems. But then if I take this as x1, and if I take this as x1, and if I take this as x2, then x1 and x2, so let's say that this over here is x1 and this over here is x2. So in that case, x2 minus x1 is going to be x2 minus x1 is going to be basically negative 3 minus 2, which is equal to negative 5. And since a distance cannot be a negative value, I'm going to have to write this as x2 minus x1, and that's basically the whole story here. So then when this happens when basically this happens when PQ is a line segment parallel to the x-axis, or you could say that when PQ is a horizontal line segment. And that's basically the whole story here. Now let me go back over there. So number 3 is the absolute value of y2 minus y1 and the absolute value of x2 minus x1. So this is something useful that you can use in many different situations, of course. And then and that's basically why these exercises are useful in many different cases. I mean, I would say in all different cases, even when you're proving something which seemingly doesn't have any basically my assumption is that you want to learn mathematics. You don't want to pass any exams, or you don't care about any exams. If that's the case, then of course many of these exercises that you see over here are just proving things that you can never use in your whole life ever again. But in the process of solving those examples, you will learn some useful techniques, and then you will be able to use those techniques in many different situations. So in that sense, basically all of these exercises are very, 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 very useful and valuable. Okay, so the next question that we have is find a point on the x-axis, a point on the x-axis that is equidistant from the points from the points 7, 6 and 3, 4. So suppose that there is a point actually on the x-axis somewhere over here, either over here or over here in the positive axis or negative axis, that is equidistant from 1, 2, 3, 4, 5, 6 and 7, and 1, 2, 3, 4, 5 and 6, and from this point, which is 7, 6, and from another point 3, 4, which is basically 1, 2, 3, 4, this point over here, 3, 4. So if that's the case, there has to be some point over here, most probably in the positive axis, that is equidistant from these 2 points. So how can we find that point? So now what we can do is that I can find the distance between these 2 points, and then basically find the distance of this point from some point with coordinates, for example, x1, y1, and find the distance of this point from the same point x1, y1, and of course over here, since the point is supposed to be on the x-axis, of course the y coordinate is 0, so the point becomes x1, 0. So what that means is that I will simply find the distance of this point from this point, and find the distance between this point and this point, and if you equate them, you will get your x1 over here. So now if I call this point A, and if I call this point B, and if I call this point C, then of course by the distance formula, you know that AB, the distance between any 2 points AB, is equal to x2 minus x1 whole squared plus y2 minus y1 whole squared. And so now what we need to do is find the distance between the point A and C, for example. So AC is going to be, I take this as x1, y1 and x2, y2. So that's going to be equal to basically the square root of x2 minus x1, which is basically x1 minus 3, and whole squared. So I'm taking basically this as x1 y1, and I'm taking this as x2 y2 in this formula. Otherwise the coordinate of the points is actually x1. These two just refer to the notation that we have used in the formula. Otherwise, I'm not using I'm not changing x1 here. So I can write this as x1 minus 3 whole squared plus 0 minus 4 whole squared, and that is the distance between the point A and C, and so that's equal to, of course, x1 minus 3 whole squared, and that is negative 4 squared, which is equal to 16. So that's the distance between point A and C. Now the distance between point B and C, I can use, you can just simply forget about this, because these might actually confuse you. I'm going to take this as, for example, as point 1, and I'm going to take this as point 2, meaning x1, y1, x2, y2. So basically 7 minus x1 whole squared plus 6 minus 0 whole squared, and that's basically that, and that is equal to basically 7 minus x1 whole squared plus 36. Now, so now this is this is the distance between B and that point on the x-axis, and this is the distance of the distance between point A and that point on the x-axis, and these are supposed to be equal. So that means that I can write AC is equal to BC, which means that basically x1 minus 3 whole squared plus 16, the square root of that is equal to the square root of this, which is equal to 7 minus x1, 7 minus x1 whole squared plus 36. And so if I raise both sides of this equation to the second power, I'll get x1 minus 3 whole squared plus 16 is equal to 7 minus x1 whole squared plus 36. And then you can change, basically you can expand this, you can write, and instead of basically x1 I'm going to write x. So x squared plus or minus x squared minus 2 times 3 is equal to 6x plus 9 plus 16 is equal to basically 7 squared is equal to 49 minus 2 times 7 times x plus x squared plus 36. And so you can write this as x squared minus 6x, 16 plus 9 is equal to 25, is equal to 49 minus 14x plus x squared plus 36, and 49 plus 36 is equal to 6 plus 9 is equal to 15, 1, and 85. So instead of these two I can write plus 85, and so now I can take everything to one side of the equation, meaning that x squared, and actually you can simplify this by basically simplifying x squared here and here, and negative 6x plus 14x, negative 6x plus 14x plus 25 minus 85 is equal to 0, and 14x minus 6x is equal to basically 8x, and negative 85 plus 25 is equal to negative 60 is equal to 0. So you can write 8x is equal to 60, divide by 2, you'll get 4, divide by 2, 30, divide by 2, 2, divide by 2, 15. And you get x is equal to 15 halves. X is equal to 15 halves. So that means that this point over here is actually 15 halves, comma 0, if my answer is right. Number 4. The answer is actually right. And 15 halves is actually 7.5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and 7.5. This is 15 halves. And so the distance of this point, these two distances are supposed to be the same. Meaning that if I call this point C with coordinates 15 halves, comma 0, then you can say that AC is equal to BC. That's basically this exercise over here. So now question number 5 is find the slope of a line which passes through the origin. So origin is O 0, 0, and the midpoint of the line segment and the midpoint of the line segment of the line segment joining the points P 0, negative 4 and B 8, 0. Okay, so to understand the question, you want to find the slope of a line that goes through 0, 0, and another point is the midpoint of the line segment joining these 2 points. So the midpoint of this line segment is, we need to calculate the midpoint of this line segment, meaning that the midpoint of these 2 points, meaning that you have basically 0, negative 4 is over here. This is 0, negative 4, and 8, 0 is 1, 2, 3, 4, 5, 6, 7, 8. It's 8, 0. And this line segment over here, it has a midpoint somewhere over here. This has some coordinates, for example, x1, y1. So we want to find this x1, y1, and then basically using this point, x1, y1, and this point over here, we want to find the slope of the line going through this point and this midpoint. So in order to do that, what you need to do is, I don't remember the midpoint formula. Let me see. The midpoint formula, let me find the midpoint formula. I'll be right back with you. Okay, so the midpoint formula, you can derive it from the formula that we used for the coordinates. We said that the coordinates of a point, dividing the line segment, joining the points x1, y1 and x2, y2 internally in the ratio m to n is basically, so you have the coordinates of the point dividing the line segment joining the points x1, y1 and x2, y2 internally in the ratio m to n, meaning that, for example, let's say that you have 2 points over here. Let's say that this is x1, y1, and this is x2, y2, and internally this, for example, there's a point over here that is basically dividing this point in the ratio, for example, m to n. And the m to n, for example, let's say over here is for example, is equal to 2 to 3, for example. Meaning this ratio m to n over here is equal to 2 to 3. So, so if that's the case, then the coordinates of this point, for example, let's call it P, the coordinates of this point P is going to be equal to mx2 plus nx1 over m plus n, and basically my2 plus ny1 over m plus n. Now if this is supposed to be the midpoint of these 2 points, then the ratio is going to be basically 1 to 1. If P is the midpoint, then the ratio m to n is 1 to 1. So if the ratio is 1 to 1, then this formula becomes basically x2 plus x1 over basically 1 plus 1 is equal to 2, and over here you will have y2 plus y1 over 2, and that's I suppose is called the midpoint formula. The midpoint formula, or at least I think it's called that. So now that we know enough about this, I can go up here and find the midpoint of these 2 points, and these are of course necessary concepts to master before you can do more advanced things in analytical geometry. So now the points over here are basically 0, -4 and 8, 0, and you want to find the midpoint of these 2 points. So the coordinates of that point, if I call it for example P, the coordinates of that point is going to be basically x1 plus x2 divided by 2 and y1 plus y2 divided by 2, which is equal to basically 0 plus 8 divided by 2 and -4 plus 0 divided by 2, which is equal to basically 8 divided by 4 is equal 8 divided by 2 is equal to 4, and -4 divided by 2 is equal to -2. That means that point is going to be at 1, 2, 3, 4 and -2, somewhere over here, for example. So that would be 4, -2. Now that you know that the 2 points that you need, so now you need that one of the points is O, 0, 0, and the other point is P, 4, -2, and you want to find the slope of the line going through O and P, meaning that going through this point and this point, you want to find the slope of this line, which is, as you can see, of course the slope is negative here. That we can find as well. Okay, so now that we have the 2 points that we were looking for, what we can do is basically use the 2 points, meaning that one of the points is 0, 0, the other one is 4, -2, to find the slope of this line over here. And the slope of the line is, as you know, is basically tan of theta is equal to m is equal to basically y2 minus y1 over x2 minus x1, and the theta that we are referring to is actually this theta over here. So that's your theta. That's your theta, which is an obtuse angle. So, but that's not really important here in what we are doing right now. Now you can write this as you can you can write this as basically y2, for example, -2 minus y1, which is equal to 0, and then x2 over x1, which is x2 minus x1, which is 4 minus 0. 4 minus 0. And as you can see, when you are, and that's equal to basically -1/2. -1/2. And there is one interesting thing here that you can see from these exercises, from this exercise in particular, and that is, let me see what I have here. And what that is that basically when you're calculating the slope of a line that goes through the origin, this line does go through the origin 0, 0. It's if you have any point on that line, if you do have any point on that line, you can divide the y-intercept of that point by the x-intercept of that point, and there you will get the slope of that line. Meaning that, for example, let's say that you have this line over here. Let's say that this is your x-axis and this is your y-axis, and you have 1 and 1 over here. And then if this line goes through the origin this way, then basically 1, 1 is 1 point on the line, and the other, and it does go through the origin. So the slope of the line I can calculate by dividing the y-intercept by the x-intercept, which would be basically 1 divided by 1, which is equal to 1. So the slope of this line, as you can see, is equal to 1. Which is something interesting that you can use in many different situations. So basically in this particular case, in the case of question number 5, that the slope is -1/2, which is actually the right answer. So okay, so what I'm going to do is that I'm going to end this video, and then we will continue with question number 6 in the next video. I'll see you in the next video.